begin properly on this, suppose we were to have a look at, say, 6 meters. This is a unit of measurement. They're saying there's 6 of them. Meter, unit, unity, 1. So it is in fact 6 of 1 meter. This is your unit of measurement. This is the count of how many of them you've got. So in fact it is 6 times 1, and I'll put M for meter. Just that the people don't bother to write the times or the 1. They just write 6 meters. This bit here is understood to be there. Now keep that in mind. So if we have, for example, 6 meters, all right, 6 times 1 meter, and I want to divide, put that in a bracket, and I want to divide that by, say, 3 of 1 meter. Normally they say how many times does 3 meters divide into that. What we end up with here in fact is 6 times 1 meter all over 3 times 1 meter. Now let me split that, in that we have 6 over 3 times 1 meter over 1 meter. This is using a hammer to crack a nut type thing. Now that is exactly the same situation as if you have, for example, 2 over 2. It becomes 1. So that little friend there becomes 1 times 6 divided by 3. 6 divided by 3 in fact equals 2. So you can see the mechanics of how this actually works. These, in fact, the units of measurement in this case cancel out. They have gone away. Which is why when you say 6 meters divided by 3 meters, the units of measurement disappear. We end up with just a count. We're saying how many of those will fit into that, and the answer is 2 of them. The units of measurement disappear. You have to understand this basic principle. Now, another thing we want to look at is, when I select the right thing, the word per. That means for each of something. So in other words, it's for one of something. That relates to one of something. So if we have 6 miles per hour, what they're saying is 6 lots of 1 mile, right? There's that little thing again, per 1 lot of 1 hour. That's your unit of measurement, that's your count. Per is for each. Now, another way of writing it, you can, wait a minute, hang on. You can do it if you like. I will write it like this, as a ratio. Now you can do that. Or you can do this. Which is why this little friend here, they're both ratios. When you say 6 miles per hour, they sometimes, oh wait a minute, got that wrong. You sometimes see it written 6 miles. This little friend here is the same as that. It's just another way of writing it. They are the same thing. But don't forget, we've got this situation here, which people don't write anymore. They don't write that. They write this instead. But keep in mind that it's that. Right, coming back to our miles per hour, we have 6 miles. I'm going to do it this way, for 1 hour. That is our ratio. I'm going to put a bracket around it. So in 1 hour we travel 6 miles, or 6 miles takes 1 hour, depending upon which way you want to look at it. Suppose we wanted to find out how far we would travel in 6 hours. So this 1 has to change, has to become 6. 1 multiplied by 6 gives me 6 hours. But because I've multiplied that by 6, I have to multiply that by 6. In that we now have that little friend there times 6 as well. I'll show you something else in a moment, right? 6 is 36 miles. This type of thing here is exactly the same. People don't do it, so I suppose some would say it's bad practice, right? But bear in mind, I'm looking at this a slightly different way. You know, in brackets you can have, for example, x plus 3, and you can multiply the whole thing by 2, where everything inside is multiplied by the 2. Well, technically you can do the same thing here, but people don't do it. I would suggest you don't do it, because they'll say, no, you're wrong, but you're not wrong, right? But they will say you're wrong. You could go, you want that to become 6 hours. You want the 1 hour to become 6 hours. So we multiplied the whole thing by 6. So we have 6 meters to the ratio of 1 hour. And the whole thing is multiplied by 6. 6 times 6 is 36 miles. 6 times 1 is 6 hours. All right? You see the way that works. Don't do it, because people will pull you up on it. Right? But I'm just trying to get you to think about this in a particular way. Right? I want you to really focus on the numbers and how they behave. Returning again to the 6 miles per hour. Or if you like, 6 miles per hour. You should really put a 1 there, but again, people don't bother. Suppose we wanted to find out how long it would take to do a particular journey. Now we can represent this as a ratio. In fact, it's exactly what it is. It's a ratio. We could do 6 miles to the ratio of 1 hour. Or if it's convenient, we can turn it upside down. It all depends on how we want to use the stuff. You could have 1 hour for 6 miles as a ratio. It all depends on what we want to do. Now, I want to find out how far we would travel if I travelled for 16 hours. What I want as an answer is just miles. So I need to get rid of the hours. Now, do you remember me saying that really this is 16 lots of 1 hour? Right, let's look at this here. Yes, we've got there 6 lots of 1 mile. Here we have 1 lot of 1 hour. Now I want to get rid of this here. Remember me saying if you have hours over hours, it cancels out. So we need to end up with this type of situation here. So if we multiply that by hours, we end up with this condition here, because you can separate out. We can separate out. And here we go. I want to know how far we travel in 16 hours. So we want 16 hours. So if I multiply that by, and I'll put it in a bracket, 16 lots of 1 hour, units of measurement. People don't normally write it that way, remember, they write 16 hours, alright? That's how they write it, but this is what it is. Now I'm going to move the numbers around, and I'm going to separate out the units of measurement. So we've got unit of measurement here, unit of measurement there, and there. So we're just going to be looking at the numbers. 6, there's your 6, over 1. Let's start with that, and that, that's a times there. Now we got that 16 there. Now I separate out the units of measurement. Now notice there's times here. Right, so we've got times 1 mile over 1 hour. Let's dealt with those two. We've got a times here, 1 hour. Now I can move these around in that we have 6 over 1 times 16. Now I'm going to move stuff. Times 1 mile. There's the 1 hour. That's that one. Now I'm going to move that one such that it's under here. That becomes the equivalent of 1. So they cancel out because you're multiplying that by 1. The only unit of measurement we have left now is miles, which is what I wanted. So it's 6 times 16. 6 6s are 36. 1 6 is 6 and 96. So, and I've got miles there. So really they would write it as that. Not bother with the multiply, not bother with the 1. This is how units of measurement work. Let's do another one, because your mind will be going, let's do another one. Suppose we have a drum, a container, and we've got a side view of it. Here, that's your container. And within it is some water. Coming out the side of it is a tap which will let water out. The height of the tap, because of course once the water's reached that point it won't go below this tap because it can't drain out, it will stop there. So suppose that volume there, V for volume, is, let's just pick on the number 80. So volume of the container is equal to 80 litres. Right? I'm going to put L for litres. How much comes out? How much comes out? Suppose the volume, that's the tank by the way, yeah. Tap volume related to time. Suppose we have how much we have? Half a litre for each, like miles per hour, per 3 minutes. Okay, so the ratio for that, we can either have, that's 0.5 litres over 3 minutes, or we can do it the other way round, depending on what we need to do. It doesn't matter, you will still have a relationship that is correct. You can turn them upside down. What I want to know, if it does that, how long does it take time to, I'll use the word empty. In other words, for this surface here to come down there. Now we're going to assume that the rate of water coming out is constant. It won't be, not in real life, but we're going to assume it's constant. Right, what we want is time. We want that to be an answer. So we need to get rid of litres. Now, litres is down here, so we could do multiply by time. Litres is up there, so that one is no good. That's the one we want. So what we end up with is 3 meters .5 litres times, now we want to get rid of that, .80 litres. Those two will cancel out. These are the only numbers you've got available. So we have to use that one and that one and that one, the only numbers we got available. And this one being up there, we can change it to 3 meters times, now look, 80 litres. I can quite legitimately move that across to under here. The units of measurement cancel out. Now we have got the only unit of measurement left is minutes. 80 divided by half times 3. Right, so that would give me, how many halves would go into that? Well, that's 160. Right, so that becomes 160. No units of measurement because they've cancelled out. Times 3 minutes. The only unit of measurement left. These have gone. So we end up with 3 lots of that. So that would equal 3 times 0 is 0. 3 6s is 18, carry 1. 3 times 1 is 3, plus 1 is 4. Only unit of measurement left is m, minutes. Done. Units of measurement will cancel out. That is the thing you need to keep in mind. How do I cancel out what I don't want to be there?